Big companies like Anthropic and OpenAI selling you context window is a lie. Not in the technical sense, as the tokens are real, but in the architectural sense. Every major coding harness, no matter if it's Claude Code or Codex, they are designed to treat context window as a bucket you fill until it overflows. Then you compress the overflow and keep going. That compression is lossy. Every session you run, you are working with a model that knows slightly less than it did 2 hours ago. And surprisingly, Claude Code was designed this way on purpose. It was the right call in 2024, but not in 2026, as on August 5th, a startup called Prime Intellect shipped a harness that argues it is the wrong call now. The project is called Prime Agent. It is open source, MIT licensed, and it scored 95.5% on ARC-AGI3 with Claude Opus 5 above the reported human expert baseline. That number will mean more once you understand how it was produced. So this whole video is around context rot and going head-to-head between these two harnesses. But before we go head-to-head, let's first understand what harness actually is. So a harness is everything around the model. The terminal interface, the file and shell tools, the loop that feeds results back in, the system prompt that opens every session, and the context management logic that decides what stays in the window and what gets thrown out. The model is the engine. The harness is the rest of the car. Currently, the most popular harness is Claude Code, an Anthropic's factory build, welded to their models, priced at $20 to $200 per month, and optimized for developer ergonomics inside a single frontier model. Its context management strategy is compaction. When the window fills, it summarizes what happened and keeps going. That summary is a lossy operation. Every compaction discards information the model will never see again. Over a long session, this compounds. That is the rot. And on the other hand, Prime Agent is Prime Intellect's answer. It is built on two abstractions. The first is the Recursive Language Model, or RLM, and the second is the Continual Harness. Both are ideas with academic papers behind them. Together, they change what context rot even means. Now let's start the actual video, so we will be comparing Byth harness on 5 different rounds from architecture, context rot to benchmark number. Round 1, the architecture. A standard agent harnesses give the model a fixed menu of tools: read file, write file, run bash, call an MCP server. Every result comes back as text that gets appended to the context window. And this whole process repeats again and again. But Prime Agent inverts this. It gives the model one tool, a persistent IPython kernel that lives for the entire session. Unlike Claude Code, there is no fixed tool menu. Every file operation, every shell command, every subagent spawn, all of it happens as Python code the model writes and executes inside that kernel. And what this means is that outputs do not have to go into the context window as text. Output live in Python variables. The model reads them programmatically when it needs them. This is what the RLM abstraction actually means in practice. Context becomes a variable, not a wall. So whenever a task needs to reason over a 128,000 token codebase, the model does not read the whole thing into the context window and watch it displace everything else. It loads sections into variables, processes them in code, and keeps the active window clean. The data lives in the kernel. And the context carries only what the model is currently thinking about. While Claude Code describes its 27 tools at the start of every session, that burns roughly 33,000 tokens before the user types a single word. A logging study that hit the Hacker News front page measured this. Prime Agent opens with significantly less overhead because the IPython kernel replaces the entire tool schema. One persistent repel instead of 27 described interfaces. Round 1 to Prime Agent on architecture. Round 2. Context rot. Context rot has a specific shape in Claude Code. The session starts sharp. By turn 20 on a large codebase task, the agent is reasoning over compaction summaries of compaction summaries. The original file structure, the early decisions, the error messages from 3 hours ago, all of it has been lossy, compressed, or silently dropped. And you will usually notice this when the agent starts redoing work it already finished. Prime Agent attacks this problem at the root. Because the IPython kernel, which we talked earlier, stays persistent across the entire session, the agent can store useful state outside the active context window at any time. A codebase analysis that produced a 40,000 token result lives in a variable, and model can access these relevant pieces of it on demand rather than carrying the whole thing. And past sessions are not gone. They can be accessed through the session JSON. Now to get a clearer picture, let us look at how these two harnesses perform on benchmarks. On Longcop Mini, a long reasoning eval, Prime Agent with Opus 5 scored 0.722 against Claude Code's 0.558, a gap of over 16 points on a task that is specifically about maintaining coherent reasoning across a long trajectory. On many H coding, long instruction following for code, Prime Agent scores 0.536 against Claude Code's 0.522. Smaller gap, but it holds even while using a model that Claude Code was not trained around. The one honest caveat: these benchmarks were run and reported by Prime Intellect. Independent replication has not been published yet. Treat the absolute numbers with appropriate skepticism. The direction of the results, however, is consistent across multiple evals. Round 2 to Prime Agent on context rot. Round 3, the Continual Harness. This is the round that does not exist in any other harness. Claude Code's system prompt is fixed. It was written by engineers at Anthropic, it opens every session, and it does not change based on what you did yesterday. Claude does not have ability to learn that you always retry flaky tests 3 times, or that your auth module has a specific edge case pattern, or that spawning a shell check before a write saves 40% of your error recovery turns. Those patterns only live in your head. The harness remains static, but Prime Agent handles this using a mechanism called the Continual Harness. The harness state its prompts, skills, memories, and subagent specs is exposed as a Python object the model can read and write mid-session. When the model notices a recurring failure pattern, it can call refine, run, and log the pattern as a memory. When a reusable tactic proves out, it can promote it to a skill. The base system prompt stays immutable. Only the surrounding layer gets updated. So to explain this, Prime Agent ran a factory building session across multiple hours. The refinement loop turned repeated failures into harness memories and successful patterns into skills. The agent's production score improved run over run as it built on its own accumulated experience. The same mechanism also discovered that it could teleport resources directly into assembly machines through Archon commands. It then optimized its cheating skills with the same refinement loop it had used to optimize legitimate ones. That is not a marketing line. Prime Intellect put it in the launch blog. The honest version of self-improvement includes reward hacking as a failure mode. Round 3 to Prime Agent, with a warning label attached. Round 4, the benchmark number. Prime Agent with Opus 5 scores 95.5% on ARC AGI 3, the number Prime Intellect leads with, and the number that got everyone's attention. And if you do not know what ARC AGI 3 is, it's the 2026 generation of the ARC reasoning benchmark, redesigned around agentic tasks. An agent explores a grid world game, infers a goal that is never stated, and acts efficiently to reach it. The headline metric is RHA, relative human action efficiency. A system that solves a level in twice the human's actions gets 25% credit, not 50%. Reaching 95.5% means solving the puzzles at close to human action efficiency, not just solving them. When ARC AGI 3 launched in March 2026, every frontier model scored below 1%. Gemini and GPT 5.4 were both under 0.5%. 5 months later, Prime Agent with Opus 5 reports 95.5% across 3 runs, with all 183 levels complete. Prime Intellect explicitly notes that no model has been trained around Prime Agent yet. What they are showing is harness uplift on a model that was not designed for their system. If model harness co-training happens, which they have announced as the next step, the gap could widen. It could also narrow if Anthropic trains a future model specifically for long-horizon agentic tasks. What the number confirms is that the RLM architecture is not a theoretical claim. It is producing measurable results against a model it was not built for. Round 4. The number is real, and the caveat is real. Split decision. Round 5. The bill and the trust. Claude Code costs $20 to $200 per month, depending on your tier. For heavy agentic workloads, the max plan covers usage that would cost 4 figures at API rates. That is the subscription argument, and it is legitimate. Prime Agent is free, MIT licensed, installs with a single curl command on Linux or Mac OS. It works with whatever frontier model you already pay for Claude, GPT, Gemini, or an open weights model running on your own hardware. There is no Prime Intellect subscription. Your marginal cost is the API bill you were already paying, or electricity if the task fits a local model. The trust question is newer. Prime Intellect is a startup that hit a $1 billion valuation on a $130 million Series A in July 2026. Prime Agent is their most visible public artifact since. The benchmark numbers are vendor reported. The Continual Harness's self-improvement loop runs model-generated Python and shell commands with your operating system permissions. The worker and kernel boundaries manage session lifecycle. They are not a security sandbox. Prime Intellect says this explicitly. If you run Prime Agent on a machine, you are running model-generated code with your own permissions. Claude Code's trust record has its own entries. Anthropic blocked developer subscriptions routed through third-party harnesses, wrote a ban into its terms of service, and sent legal demands to an open source project. The Hacker News thread on that story was not charitable. Whatever the reasoning, the message was that the subscription is licensed to their harness, not to you. No clean winner here. One side has legal leverage and no self-modifying code. The other has more transparent pricing and a reward hacking case study in its own launch post. 5 rounds. Context architecture, Prime Agent. Context rot, Prime Agent. Self-improvement, Prime Agent with a warning label. The benchmark, split. The bill and trust, split. The picture that emerges is this. Claude Code was designed when frontier models were shorter horizon tools. Its compaction strategy made sense for tasks that fit inside a single context window with some headroom. Prime Agent was designed for tasks that do not. Long codebase analysis. Multi-hour autonomous runs. Tasks where the agent needs to build on its own prior work across sessions. That is the gap it is targeting. The caveat that matters, no model has been trained around Prime Agent yet. The numbers you see now are harness uplift on models that were not co-designed with the system. Prime Intellect's own next steps section calls model harness co-training the dominant paradigm for unlocking new capabilities. They believe the current results are the floor, not the ceiling. If you want to see what that floor looks like, the install is one command. If your work lives in long horizon tasks, give it a session this week. If you are doing shorter work that fits inside Claude Code's compaction budget, the subscription still makes sense. The harness you pick is your long-term relationship. Context rot is not a Claude Code bug. It is a design assumption that Prime Agent has decided to treat as a solvable problem.